Welcome to Summation Notation Part 4. Use the properties of summation and Theorem 6.2 to evaluate the sum. Use the summation capabilities of a calculator to verify your result. Sigma I cubed plus 3i from I equal 1 to 11. Do you remember sigma I cubed? And what's the relation between it and sigma I? Sigma I cubed from I equal 1 to n is n squared, n plus 1 all squared over 4. It is the same as sigma I, but we square everything, where sigma I is n into n plus 1 over 2. They are very related to each other. Now to find this sum, we have to find the sigma of each part separately. So we can write our problem as sigma I cubed from I equal 1 to 11 plus sigma 3i from I equal 1 to 11. We prefer to take this 3 outside the sigma because it's constant multiplied by I. In this case, we will apply the rules that we revised before. The first one is n squared into n plus 1 all squared all over 4. What is the value of n of this problem? It's 11. So the first part is 11 squared into 12 squared, which is 11 plus 1 all over 4. Plus, don't forget to write the 3. And what is the sigma of I? It's n, which is 11 again. N plus 1, which is 12. But this time we divide by 2. All we have to do is to plug in this expression into our calculator to get the result. The result in this case is 4,554. You can check this using your calculator. This was the first example. Now let's go to the second one. Find sigma 7i from I equal 1 to 15. Do you remember how can I find sigma I? Now remember that n is 15 this time. N is the upper end. But how about sigma I? And where will we take the 7? 7 will be outside the sigma. And sigma I is n into n plus 1 over 2. Don't forget this. Now let's do our calculation. First, write the 7 before the sigma, and then find the sigma of I from I equal 1 to 15. Substitute in the formula of sigma I, but don't forget to write the 7 first. So it is 7 multiplied by n, which is 15, n plus 1, which is 16, over 2. It remains only to use our calculator to carry out this calculation. So the result will be 840. You can check this again using your calculator. The last example in this video is to find sigma when x approaches from 1, when x changes from 1 to 14, from 1 to 10. Sigma I squared plus 4 from I equal 1 up to 10. Sigma I squared plus 4 from I equal 1 to 10 consists of two sigmas, sigma I squared and sigma 4. Sigma I squared, it is the longest one, because sigma I squared is n plus 1, multiplied by 2n plus 1, all over 6. Remember, this is the longest one that we have to memorize. So, we are going to substitute this formula to find sigma I squared. But what about the 4? Again, we will divide our problem into two portions. Sigma I squared from I equal 1 to 10 plus sigma 4 from I equal 1 to 10. Let's calculate the first one first. Sigma I square from I equal 1 to 10. Then sigma from I equal 1 to 10 also of 4. The last sigma is sigma of a constant, so it's just multiply 4 by 10 to get it. This constant multiplied by n. Do you remember this formula? It is the first rule. But with respect to the first part, I have to substitute in this long form. So it is n, which is 10, into n plus 1, which is 11, into 2n plus 1, which is 21, all over 6. This is the substitution of sigma I square. Plus, what about sigma 4? As we told you, we have to multiply 4 by 10. Don't forget to use your calculator to get the final result, which is 385 for the first part plus 40 for the second part, which comes to 425. This is the last part of this video. Thank you. See you next video.